completing details to run the first simulation. 64. On cell K19, sum the total amount of event risks for the project with the formula equals sum K16, K18. 65. On cell K21, sum the activity costs plus the event risks to obtain the total probabilistic cost for the project with the formula equals K13 plus K19. 66. Cell K21, the total project cost should now be declared an output cell. On top of cell K21, click on the Add Output icon on At-Risks ribbon. At-Risk immediately generates this window where you can edit the name of the output. By default, At-Risk obtains the first text on the same row to the left-hand side of the cell, in this case the text total cost, placed on cell A21, and then, separated with the slash, the text it finds on the same column above the cell, in this case the text event risk found on cell K15. Sometimes this naming feature is useful to efficiently use these implicit names. Sometimes, however, these implicit names do not make too much sense. In this case, just leave the name total cost by removing all text after the slash. 67. Click on the OK button and observe how At-Risk has created the following clause on cell K21. Equals risk output, open parenthesis, quotes, total cost, quotes, close parenthesis, plus K13 plus K19. You can also replace total cost for a reference to cell A21 to convert this name to a dynamic one. Thus, if the text in cell A21 is replaced with another text, its reference to this named output will also dynamically change. Equals risk output, open parenthesis, A21, close parenthesis, plus K13 plus K19. When a cell is designated as a simulation output, a risk output function is added to the cell formula. These functions allow the easy copying, pasting, and moving of output cells. You can also type risk output function in formulas the same way you would type in any standard Excel function, bypassing the add output command. At least one output, total cost, has been added to our model. 68. To view at this point the composition of inputs and outputs having been added to our model, you can click on the model window. At-Risk will now display the following window containing tabs for inputs, outputs, correlations, and statistic functions. At the upper right-hand corner of this window, you should be able to verify that the model contains 28 input variables and 1 output variable. 20 of these variables come from activity costs, respectively the quantities and unit prices. 8 of these variables come from the event risks. The first event risk has a multiplication of 2 distributions, whereas each one of the 2 remaining events is structured with compound functions that require 3 functions each. 69. Go to the Simulation Settings button and make sure on the first General tab, the number of iterations has been set up to 10,000 iterations and 1 simulation. On the third tab, Sampling, make sure sampling type has been placed on Latin Hypercube, Generator on Mersenne Twister, the initial seed has been fixed on any number. In this case, we will arbitrarily insert the digit 5. And multiple simulations all use same seed. On other options, collect distribution samples has been placed on all, smart sensitivity analysis has been disabled, and update statistic functions will be set at the end of each simulation. Leaving all these settings will guarantee that after the simulation is run, the simulated results we are running and interpreting should yield exactly the same results. Changes on these parameters may result on slightly different simulated results. 70. On the At-Risks ribbon, turn on your demo mode. This is a preset view where At-Risk updates the workbook each iteration to show how values are changing and displays an updated graph of the first output in your model. This mode is useful for illustrating a simulation in At-Risk. Demo mode can also be toggled on and off on the View tab of Simulation Settings. 71. Start to run your simulation for 10,000 iterations. Remember that during a simulation run, you can control the way in which simulation results are displayed by clicking on the small icons on the Simulation Progress window. For example, you can either turn on or off the display for Excel updating and for the chart to update itself 10,000 times. By clicking on either one of the first three icons on the Simulation Progress window, the user is able to toggle on and off the display of updating a summary window, the Excel spreadsheet model, and the output chart being updated. Leaving these options on can be very demonstrative for users who want to understand the nature of the Monte Carlo simulation process. However, this demo mode on is significantly slower than running your simulation with both options, updating Excel and updating the output chart, off. Both options can be turned on and off any number of times during the simulation run. Do notice also that the forecast calculated runtime and iterations per second calculations change under different settings for both options. On the other hand, the choice on 10,000 iterations is just a recommendation. Any number of iterations can be defined from 1 up to 32 million. In general, the larger the number of iterations, the better the precision or convergence of the results, but also the longer time it takes the simulation to run. Achieving convergence on precision on your model becomes an ever-increasing demanding task, as such convergence achievement behaves decreasingly on a non-linear fashion.